Hi, I'm Tim Berglund with Confluent. Welcome to Data as Product. So this is the second principle of data mesh, treating data as a first-class product. Honestly, when you're first trying to get data mesh into your head, I think this is the most important principle to focus on. You've got to really own this, and some of the rest starts to make sense. So this is about product thinking. Your domain's shared data is managed as a true product. And your objective is to provide this data in a clean and proper way so other teams can make use of it. In other words, you treat the other teams as internal customers of your data. Your data isn't just stuff you insert and update and delete in a database to get your job done, but this is something you're publishing to people as something that you're proud of. This product thinking is so important, and it prevents what we call data chauvinism. That's a risk of Principle 1 that we covered in the previous model, thinking too much in closed terms. This is just our data and it's the good stuff and nobody else's data matters. Nobody needs to see our data. We don't want that. Decentralization and granting local autonomy over domains can cause the creation of even more data silos. We wouldn't want that, and serious data quality problems if the origin domains only care about themselves. So they really have to look at themselves as servants of the rest of the organization in terms of the data they publish. So what's a data product? Well, let's keep going. Think of a data product as a microservice for analytics or a microservice for the data world. It's a node on the data mesh situated within a particular domain of the business. The role of the data product is to produce and maybe also consume high-quality data within the mesh. And like a microservice, it encapsulates everything it needs for its functioning. It's all right there, all right? You've got the actual data we want to share with the outside world, the code that creates it and that manipulates it and shares it, and the infrastructure that we need to store the data and to run the code. So it is really pretty similar to a microservice. It's just its purpose is publishing data and not delivering compute. So before we take a closer look at a data product, let's finish the zoom out again and look at the bigger picture of the data mesh. Because really a key question here is, how is data shared across data products in the mesh? That is, how do we implement the links and connections between the nodes in the network? And even visually, in this diagram I'm showing you hypothetically here, we can see that this interconnectivity lends itself very naturally to, you saw this coming, event streaming with Kafka, right? This seems like a natural fit. So here, data is provided to other data products through streams in Kafka, or topics if you prefer to call them that. Any other data product can consume via Kafka from the high-quality data streams of other data products. This is really a hand-in-glove match as I look at it. As we can see here, this idea of a data mesh is very similar to the Confluent's idea of a central nervous system, the way we talk about event streaming, where data is continuously flowing, being processed, analyzed, acted upon. These things go together well. Of course, we have to remember that the data mesh shown here is a logical view, okay? We're trying to get data mesh into our heads here, and these nodes are these local pieces of domain-specific data functionality, publishing products to other nodes. This isn't a physical view. That physical view would be Kafka topics exchanging messages. So if you know Kafka, you know that the reality there looks a bit different and even potentially simpler, which is a good thing. That's because event streaming isn't a point-to-point architecture that leads to the spaghetti mess we saw in Module 1 and that a lot of us have experienced painfully in our own lives. So instead, it's an architecture that decouples data producers from consumers in a scalable way, also a fault-tolerant way, and a persistent way because streams are durably stored. So here, a data product talks to other data products only indirectly. It's not point-to-point. Really, one is producing messages to a topic and another is consuming from a topic or a stream. And this layer of indirection, it's those topics or those event streams in Kafka. So this setup is write once, read many. And all a data producer has to do, one of these nodes, to participate in a data mesh, is to publish its public data as streams, and then other data products can independently consume the data the way they see fit. Now, look, we've got some naming things to work out, some schema things to work out. There are some implementation details, but you see how well Kafka as a basic piece of data infrastructure and data mesh go together. As a quick refresher, let's recap the properties of event streams and why they're such a great fit for this. So here are some of the reasons you see here. For example, streams are real time, right? You could propagate data throughout the mesh pretty much immediately as soon as new information is available. Streams are persistent and replayable. They let you capture real time and historical data with one step. And they're immutable, right? So they make for a great source of record, which is great for governance purposes. And, this approach of loosely coupling things together through event streams and Kafka, sort of already a thing for microservices, right? Again, we see that parallel. So let's get back to data products and the question of how do we get data into and out of a data product? There are three main options. One is just use event streams. We just discussed why this is a good fit in a data mesh. And, another strong advantage is that they continuously import and export data as soon as new information is available to the business. Two, you could use request response APIs synchronously to request a data snapshot on demand, like a file export. That could still have a place in the system. Three, you could use traditional ETL for batch import export of nightly snapshots. This will give you a fixed cadence of importing and exporting these snapshots, but compared to option B, less control over exactly what snapshot data you'll be working with. With event streaming, you can quickly onboard data from existing systems through Kafka Connect and connectors that stream data from those systems into the mesh in real time. There are about 200 of those in existence at the time of this recording in the early summer of 2021. Those are readily available things. So in most cases, you don't have to write anything yourself. That integration is probably done for you. So it's a great way to set data in motion when you're bootstrapping a data mesh. Now that there's some data flowing into our product, what's happening then? Well, really what's happening inside a data product is kind of no concern to the data mesh. I shouldn't worry my little head about that at all. Apart from the team responsible for the data product, who are quite concerned about it, everybody else only cares about the public interface, the public data that's shared by the domain. How that public data is created, implementation details, language, data infrastructure, whatever's going on in there doesn't matter as long as it meets criteria such as being addressable, trustworthy, and good quality. That being said, the local team does care about how the data is being made. And among other interesting technologies, again, event streaming is useful to implement the insides of a data product. Naturally, you'd use streaming tools like KSQLDB and in Java, the Kafka Streams client library to process streaming data that enters a product or is created within a product. And streaming data that leaves is shared with the outside world in the data mesh in the same way. So if you're interested to learn more, we've got separate courses available for you that cover KSQLDB and Kafka Streams in detail. And of course, introductory Kafka stuff as well. This brings us to the last point. In which way should we share our data product streams within the mesh? So the two main considerations here are the use of schemas and versioning. When you publish a stream, you should use schemas with appropriate backwards and forwards compatibility. This ensures, for example, that when you add a new data field to a stream, that any existing consumers of that stream can continue to operate without having to make any changes. However, if you do need to introduce breaking change to the schema of the stream, then use versioned streams. For example, if you're being required to obfuscate certain data fields moving forward, which likely does break existing consumers, then publish a new version of your stream and deprecate the original once no one is using it anymore. So we really see here that data on the outside is harder to change, but it has more value for the organization at large. Because of this, you should use schemas to put data contracts in place. There'll be situations in practice where a data product is forced to make incompatible changes to its schemas. This happens. The world changes, and we have to deal with it. And you could address that using the dual schema upgrade window pattern. I was kind of just hinting at that a moment ago. The next recommendation is that in a data mesh, you should always favor getting the data from the source rather than from intermediaries. Otherwise, data quality will deteriorate. It's like a game of telephone. More and more, the more edges you've got in that graph, it's going to get worse no matter what. Thankfully, it's easy to circumvent this problem through event streaming. With event streaming, you can easily subscribe to data directly from its authoritative source. Third thing we see is to change data at the source whenever there's a need for such a change, like the case of fixing an error. You shouldn't fix data up locally as you consume it for reasons we mentioned earlier in this module with the Alice and Joe example with orders and inventory. Finally, you'll soon see that some data sources will be difficult to onboard into a data mesh as first-class data products. This can be for many reasons, which are either going to be really organizational or technical. For example, batch-based sources often lose event-level resolution. There can be some non-reproducible, events can be non-reproducible in those sources. In such a situation, we use event streaming together with maybe change data capture, the outbox pattern, things like that to integrate those difficult sources into the mesh. A big take-home here from this principle is to learn domain-driven design. And remember, to learn more, you could check out these other courses on Confluent Developer. That wraps it up for this lesson.